Hello again, students. This is our last video in the series for SOL G7. This is going to work on part C, which is proving that two triangles are similar using deductive proofs. Now, I've got my three similarity postulates here. The AA similarity postulate says that if two angles in one triangle are congruent to two angles of another triangle, then the two triangles can be similar. I've got the SSS similarity postulate that says if we have three sets of proportional sides, then the triangles are similar. And the SAS similarity theorem says that if you have one congruent angle pair and the sides surrounding that angle are proportional, then the two triangles are similar. So AA similarity postulate, SSS similarity theorem, SAS similarity theorem. Those are our options for this last part. So the question is, which postulate or theorem can prove that the two triangles are similar? There's that word prove. Now, we are not doing a full-on two-column statement and reason proof. We are just stating how the two triangles are similar. So let's take a look at this first example here. In this first example, be very careful here. Yes, I see one congruent set of angles, so that's good. That might lead us to AA or SAS. Angle X is congruent to angle M. Okay. I also have some congruent sides, but this is a bit tricky. This is not the side of one triangle congruent to the side of another triangle. This is the side of one triangle congruent to the other side of the same triangle. What that means is that that triangle is isosceles. And if it's isosceles, then these two base angles are congruent to each other. Now, how do I figure out what those base angles are? Well, there's 180 degrees total in a triangle. We've used up 50 degrees for that top angle, so there's 130 degrees left to split between these two angles. So 130 degrees divided by 2 leaves me with 65 degrees for these two angles. Okay. Well, over here in the next triangle, check this out. The same thing's happening. A congruent side pair. So another isosceles triangle. It just so happens that this triangle also has a 50-degree angle. So these two base angles are congruent to each other, and they're following the same pattern that this triangle on the left followed. So we have 65-degree angles everywhere. We've got a lot of 65-degree angles. So we really have three sets of angles that are congruent to each other. Angle Y is congruent to angle W, which is also congruent to angle N, which is also congruent to angle P. So we've got a ton of angles congruent to each other everywhere. So I know we have at least two angles of the left triangle congruent to the right triangle. So these two triangles are similar by the AA similarity postulate. Okay, example number 2. Given side AB is parallel to side CD. Okay, so what does parallel do for us? Well, we've got alternate exterior angles congruent, alternate interior angles congruent, consecutive interior angles that are supplementary, or corresponding angles that are congruent. I'm going to go with the corresponding angles that are congruent. Angle A corresponds with angle C, so I know those are congruent, and angle B corresponds with angle D, so I know those are congruent. Now, how is that helpful? Well, check out the triangles you're comparing. ABE is the larger triangle. I'm going to redraw it here. ABE. And CDE is the smaller triangle that's stacked inside of ABE. So CDE. And we've just said that angle angle A and angle C are congruent, and that angle B and angle D are congruent. So I'm good. I'm done. What do you see? I see two sets of angles that are congruent to two other angles. So these are also similar by the AA similarity postulate. Side note, angle E down here has to be congruent to itself. So really this is the AAA similarity postulate, but we just need two angles to prove it congruent. Similar. Goodness, prove them similar. All right, last example here. The given information is the picture itself. I see something important here. I see these triangles. Those triangles tell me there is some kind of parallel lines in the picture. So if we've got this set of parallel lines, we have our bow tie problem, we've got our parallel lines. I hope you've seen it enough times to know what's going to happen. We're going to have some alternate interior angles here. Angle B is an alternate interior with angle D. They live on the parallel lines, so they are congruent to each other. B is congruent to D. We could do the same thing going down the opposite transversal. Angle A, travel down its transversal, stop at the parallel line, must be congruent with angle E, and I'm done again. What do I mean by that? I have two angles in the top triangle that are equal to two angles in the bottom triangle. So this is another set of similar triangles by the AA similarity postulate. Now all three of my examples here are the angle-angle similarity postulate. That's because that has been the most popular style of this question on the SOL over the years. So we're going to practice that. If you need more practice, check out IXLP 7. There's lots of practice there with all the similarity postulates and theorems. Thanks for watching. Happy studying.